Good evening, everybody. My name is Tricia Palmer. I am the Warning Coordination Meteorologist at the National Weather Service in Greenville, Spartanburg. We will be doing Skywarn spotter training tonight. We'll be getting started at the top of the hour or shortly thereafter. Seeing a bunch of people trickle in, so if you'll just hang tight, we'll get started here in a few minutes. All right, I have 6 o'clock on my clock. Still waiting on several people to join. I'll give it just one more minute and then we'll go ahead and get started. All right, well, we're going to go ahead and get started. Again, my name is Tricia Palmer. I am the Warning Coordination Meteorologist at the National Weather Service in Greenville, Spartanburg. Thank you for joining us this evening. We are going to be doing Skywarn spotter training. For those who were not able to join, those who registered but were not able to join live, you will be sent a recording of this training so that you can watch it at your convenience. Okay, so if you have a question at any point during the training tonight, if you're on the PC or a web, or if you're watching on your phone, please use the question box on your GoToWebinar application, the little question mark, to send in your questions. And then I'm going to try to answer as many questions as possible at the end of the class. So again, use the little question mark on the GoToWebinar application. And then just ask your questions anytime throughout the class. And then at the end, I will go through all the questions that you guys have, and then I will try to answer them as quickly as I can. All right, so the course objectives for this evening. What I want you guys to do is to gain a basic understanding of thunderstorms and severe weather, know what reports help us here in the National Weather Service, and know how to make a report to us here at the National Weather Service. So a couple of really important things right up front. This is not a storm chasing class. We here in the Weather Service, we don't ask, we don't encourage, we don't request, and we do not tell our spotters to storm chase. There are storm chasing groups out there, but they're not endorsed by and they're not regulated by the Weather Service. So if you choose to chase, you do so at your own risk. So this is just a spotting class. So it's looking outside and then telling us what you're seeing. Okay. So let's start off with a little bit about the National Weather Service here at our office in Greenville, Spartanburg, and the Weather Service as a whole. So what is our mission? So basically, we can boil it down to we're here to produce forecasts and warnings for the protection of life and property and the enhancement of the national economy. So we're not the ones actually out there, filling sandbags and placing it to, for flood protection, but we're providing those forecasts and warnings for the first responders, for the folks who are actually out there in the front lines who are doing the work, to help you guys and to help the first responders to make those decisions. So our structure, where we are in the federal government, we're part of the Department of Commerce, and then our parent agency is the National Oceanic and Atmospheric Administration. And then we have several sister agencies as we go across here in NOAA. Like for example, all the satellites that are owned by the government, all the weather satellites, they're here in the National Environmental Satellite and Data Information Services. Those of you who maybe have seen the movie Twister, that's over, and maybe you've heard them refer to the National Severe Storms Lab in the movie Twister. That's over here in the Office of Atmospheric Research. But here we are here in the National Weather Service. And then our office here in Greer, South Carolina, we call this Greenville, Spartanburg. We're what we call a local weather forecast office. So that's us here. So that's sort of our structure as we go up in the federal government. The National Weather Service as a whole, it kind of goes up and down. Sometimes 4,500 employees, sometimes 5,000 employees. It depends on how where we are in the how many people have retired at certain times during the year. But we have 122 forecast offices across the country. We have 13 river forecast centers and then 9 special centers. The ones you may be more familiar with are like the Storm Prediction Center, the National Hurricane Center. But bottom line, we're responsible for the issuance and timely warnings, forecasts, and other public weather services. And then here we are circled here in the upstate of South Carolina, but we are responsible for forecasts and warnings for the Western Carolinas and Northeast Georgia. And then zooming in across our area, you can see here, we are located right here on the border of Greenville and Spartanburg counties, but we cover 46 counties in the Western Carolinas and Northeast Georgia, all the way up to the Tennessee line over here to the I-77 corridor, the Charlotte metro area, all the upstate of South Carolina, and then we cover 6 counties in Northeast Georgia as well. About 5.5 million people in our coverage areas where we're responsible for. So what we do all sorts of stuff. We do aviation forecasts, hydrology here in the Southern Appalachians. There's a lot of very hydrologically active areas in this part of the world. Fire weather. You wouldn't necessarily think of fire weather in this part of the country, but if those of you who have been here for a while, you may remember back to the 2016 season. We had a very active fire weather season back then. We're in a bit of a drought right now, so we have some fire weather concerns out there right now. Looking forward to maybe a little bit of rain here in the next couple of days. So, so yes, we do have occasionally some fire weather seasons. Observations, we do not do balloon launches at our office. The nearest one to here is down in Peachtree City, Georgia, just south of Atlanta. But several offices do release upper air balloons. Marine, we don't have marine here at our office, but all the coastal offices do. The big thing is radar and warnings. And of course, we do at least twice a day, 7-day forecasts. And then several times throughout the day, we do update what we call the near-term portion of the forecast. And then a growing area is what we call decision support services, where we provide specific forecasts to our emergency management partners as well. Some of the tools we use here at the National Weather Service, besides what you may think of normally as with our radar, but we have these advanced computer workstations, and that helps us to view the radar, satellite, and computer model data as well. So for this class, why is it that we need you guys? Why do we need the ground truth? Well, we have our radar here outside the backyard here in our outside our office here in Greenville, Spartanburg. And so the radar helps us to see what's going on in the storms. But as the radar releases that beam and is looking at the storms, if you look at the storm here on the left, storm A, we can't see exactly what's going on at the top of storm A. And if you look out storm B on the right, okay, we can see storm B pretty well, but we can't see necessarily what's going on the bottom of storm B. And here in our office, you know, we can look outside our windows. But say if you're in the Charlotte area, it always helps to know what's going on at the ground. So if taking this image right here, the radar is showing us what's going on inside the storm, but it's the spotter. The spotter is telling us what's going on at the ground. So it's all about this perspective. So that's where we need you guys. We need you guys to tell us what's really going on. Again, we're here in our little bunker here in Greer, and we've got these few windows, but we really need folks out there telling us what's really going on the ground. The radar can help us to say, okay, there might be hail in this storm, but we don't know if the hail is actually reaching the ground. The radar can give us an idea of how strong the winds might be aloft in the storm, but unless somebody is telling us, we don't know if those winds are actually reaching the ground. So having spotters out there, having folks out there telling us exactly what's going on is invaluable. Winter weather, we've got a winter weather spotter talk coming up here later on, I believe this weekend. Knowing that there's snow reaching the ground is also very helpful as well. So by sharing the information, spotters giving us the information, we are able to actually enhance the message going out to emergency management, going out to first responders, going out to the public. So we're able to add more information to our warnings. So for example, here is just a basic warning without enhanced information from spotters. So for example, we have a tornado warning here. We've detected a severe thunderstorm capable of producing a tornado in this location. But if we know that there's a tornado on the ground, that spotters have seen a tornado, we're able to add that information to the warning. So in this case, you can see storm spotters were tracking a large and extremely dangerous tornado. So we can get that information out, and then our partners in the TV media are able to, you know, like figuratively and literally roll up their sleeves and then share that information with the public, and then we can effect that response that we really need, that people are able to get down into their shelters and take cover. So we really appreciate the dedication that you guys have to learn this information and then to share what you see with us. So let's get started. So let's talk about some science, okay? So we're going to talk about how thunderstorms form, what it is that makes a thunderstorm severe. So what's the difference between just your run-of-the-mill thunderstorm and a severe thunderstorm? The difference between a watch and a warning. We're going to talk about hail, high winds, and tornadoes, and we're going to talk about flooding, because flooding is really important around here. We actually have more fatalities from flooding than from any other weather phenomenon across the area. Okay, so thunderstorms. Only about 10% of our thunderstorms across the area become severe. So most of our thunderstorms are just your run-of-the-mill thunderstorms, you know, rain, maybe some strong winds, lots of lightning. But all thunderstorms contain lightning, hence the name thunderstorms. You have to have lightning to get thunder. So thunder is your warning that it is that it is a thunderstorm, that you've got lightning in the thunderstorm. So thunderstorms can be 5 to 20 miles across, up to 10 miles tall. And that's actually a pretty big thunderstorm right there, 10 miles tall. They can occur any time of the day or year. And they're most common between 1 and 9 p.m. during the warm months. We've all seen this happen. And that we can get some pretty good lightning shows out here, especially during the summertime. So what are the ingredients for a thunderstorm? Well, first, you need shear, and the shear is what's basically the change in wind speed or direction with height. And this will impact the type of severe weather. You really need shear for severe thunderstorms. So It'll help to determine whether you're going to get what's called supercells, and I'll talk about that in a little bit, versus ordinary thunderstorms. So like I said, this is the change in wind speed or direction with height. So lift is the second ingredient for a thunderstorm. So this is something that forces the air to move upward. So whether this is a cold front or a warm front or a dry line is just a change in basically the dew point across the area. Those are very rare to have around here. Another source of lift that's sort of a constant source of lift around here would be the terrain, the mountains. So as the wind at the surface just moves across the terrain, the mountains force the air to rise. So that's why oftentimes during the summer, we get these pop-up thunderstorms just developing on the mountaintops, and then they blow off across the Piedmont. And instability is the third ingredient. So instability is just the fact that warm air wants to rise. So if you can imagine putting a pot on your stove and then you turn the heating element on your stove. So as the bottom warms up, eventually you're going to get that warming process, and that water in your pot will eventually start to boil. Well, that's what happens during the summertime. So the sun heats up the surface of the earth, and the air right against the surface of the earth starts to heat up first, so that the atmosphere starts to sort of bubble, just like the water in your pot starts to bubble. And that's the instability. And so this is what happens again during the summertime. You get these summertime pop-up thunderstorms, and this is what we call convection. So it's the same process as the convection in the pot on your stove. So especially if you get cool air moving across a loft, that helps to create instability in the atmosphere as well. And finally, you need moisture. So we have two constant sources of moisture across the area, and that's the Gulf of Mexico and the Atlantic Ocean. And so when we get these strong southerly or southeasterly winds, that helps to bring moisture into the area. So if you remember SLIM, shear, lift, instability, and moisture, that will help you to remember those thunderstorm ingredients. And it's the shear that really helps to make a thunderstorm severe. Moisture, instability, and lift is, excuse me, is the moisture, instability, and lift that makes a thunderstorm. Okay, so how does a thunderstorm develop once you actually get a thunderstorm? So we have all the ingredients in place. So how does the thunderstorm actually start forming? So the first stage is the cumulus stage. So we get the air starting to rise, and we get these beautiful little cumulus clouds developing in the summertime. And then the second stage is what we call the mature stage. And these are the big thunderstorms that are developing. So we have the red arrows. These are what we call an updraft. And this is that warm, moist updraft. And the blue arrows, these are what we call the downdraft. So this is when you get the rain-cooled air starting to fall out of the thunderstorm. So when the downdraft is falling on top of the updraft, you can imagine that the thunderstorm is no longer sustaining itself. But if you have the shear in the atmosphere so that the thunderstorm is tilted, and the updraft and the downdraft is not falling on top of the updraft, that is when you can keep the thunderstorm going for a lot longer. And then the final stage is what we call the dissipating stage. Excuse me, I'm talking too much right now. So the dissipating stage is when the thunderstorm is run out of energy. So now the downdraft has fallen on top of the updraft. You no longer have the warm, moist air sustaining itself, and the thunderstorm is basically falling apart. All right, so moving on to severe thunderstorms. What is it that makes a thunderstorm severe? You must have at least one of the following ingredients to have a severe thunderstorm. So you have to have winds of 58 miles per hour or greater, which is strong enough to knock down multiple healthy trees. Or you have to have hail that's 1 inch in diameter or greater, which is the size of a quarter or larger. Or you have to have a tornado. So one of those makes a thunderstorm severe. All right, so let's talk about outlooks, watches, and warnings. We work in the paradigm that a lot of emergency response works in as well, the ready, set, go paradigm. So our ready is what we call the convective outlook. So this is a heads up for the potential of severe weather over the next few days. So this is when we want you guys to pay close attention to the forecast. Now our set is the watch, and a watch is when conditions are favorable for severe weather in and close to the watch area. And then the go is the warning, and that means severe weather is imminent or occurring, and this is when we want everybody to take action. So again, the convective outlook, this is that heads up period. So here are the different risk categories for the convective outlooks. And we measure this at a scale of 1 to 5. So the 1 is a marginal, 2 is a slight, 3 is enhanced, 4 is moderate, and 5 is high. So what I want you guys to understand is this high risk here, this 5 high, this is incredibly rare. We haven't actually had a high risk in our area since the mid-90s. And a moderate risk is, we haven't had a moderate risk probably since, I believe it was about 2017 was the last moderate risk. So climatologically, when you see an enhanced risk issued for our area, that's a pretty big deal. So even a slight risk, we tend to have several of those a year. You should probably pay attention to the slight risk. So these are issued by the Storm Prediction Center out in Norman, Oklahoma. And again, this is not current. This is from the big super outbreak back in 2011. So these are issued for the lower 48 states. And we have pretty detailed outlooks for days 1 through 3. And then the more general outlooks for days 4 through 8. And these generally describe the coverage and the severity of the bad weather that's expected. So again, giving you an example here, this was for our area, this was a moderate risk back in 2011. And on this day, we had an F3, an EF3 go through parts of Northeast Georgia. And I'll explain that here, what the different EF scales are here in just a second. So watch versus warning, that's our set versus go. So that watch means conditions are favorable, and the warning means to take action. So think of it this way. Watch means the ingredients are there, and a warning means that we're ready. So a watch means that we're getting ready to make cookies, and the warning means that the cookies are made. So here's just another example. So our watches, severe thunderstorm and tornado watches, they can typically cover many counties, and they're issued by the Storm Prediction Center. We don't actually issue them, we relay them from the Storm Prediction Center. We work with them very closely, and we help to determine which counties should be in and out of the watch. And they can be in effect for 4 to 10 hours, usually 6 to 8 hours or so. And again, this means that conditions are favorable for severe weather. Now, a warning, we are the ones that issue the warnings. So severe thunderstorm and tornado warnings are issued for a county or a portion of a county or maybe a few counties. And they're usually in effect for an hour or less. And it means that severe weather is imminent or occurring. All right, so let's talk about hail, specifically hail. So I showed you the thunderstorm formation earlier, and I showed you that we have this updraft, and that comes from the instability in the atmosphere. So we have that rising motion in the atmosphere. So when you're inside a thunderstorm, we have that rain, we have the updraft in the thunderstorm. So rain is lifted above the freezing level, and the rain freezes. So you can see this red arrow here, the raindrops being sucked up into the updraft. So what happens is as that rain freezes, it gets lifted up, it freezes, and it cycles back down, and it starts to fall to the ground. And then sometimes it gets sucked, that little frozen raindrops get sucked back up into the updraft, and it refreezes, and it gets more liquid, and it goes around and around and around again. So it comes back down, gets more liquid on it, it comes and it gets sucked back up into the updraft. So you can see how as it collides with more liquid rain, it grows again. Eventually, it gets too heavy and it falls to the ground. So the stronger the thunderstorm updraft, the larger the hail can be. So here's just an example here. The rings in these hailstones here represent multiple freezing cycles as that hail is lofted again in the updraft, freezes, it falls, picks up more water, is lofted again, freezes, and so on. So when you see hail, what we need to know from you is, when did it begin and when did it end? How large is it? Where are you and where was the hail, of course? And is it covering the ground? And when you tell us how large it is, please don't tell us that it's marble size. Please let us know in relation to the size of a coin or a ball. That's very helpful, because as you can see, these marbles are all different sizes up here. So give it to us in relation to the size of a coin or a ball, if at all possible. So here are some useful tips for hail size descriptions. So again, coins, pennies, quarters, balls, ping pong, golf balls, baseball. It is really rare to get baseball size hail or larger around here. It's pretty rare to get tennis ball. Usually we're going to get quarters or smaller around here. Probably in running some of the climatological statistics, baseball size hail and larger is probably on the average of once every 5 years in this part of the country. So if that just gives you an idea about how rare that is. Okay, so let's talk about damaging winds for just a little bit. We can refer to this, you might have heard the term microburst, you might have heard the term straight line winds. There are slightly different mechanisms for both of them, but just talking about the result, like down trees or whatever, the point that I want you to understand is these are not tornadoes. These are just the damaging winds from thunderstorms. So these can be from organized squall lines of storms. These can be from isolated summertime thunderstorms, whatever. The point is, again, these are not from tornadoes. So again, in our area, the most common types of wind damage we're going to see is from wet microbursts. So what is it that causes a microburst? Well, again, I showed you earlier how a thunderstorm forms, that we have the updraft, the warm updraft, and then we get the cool downdraft. Well, the updraft will hold a large amount of rain and hail suspended aloft in a storm. Eventually that updraft weakens, and eventually that updraft plummets to the ground. Well, if it plummets to the ground all at once, it will hit the ground as a microburst. So here's an example Here's this formation of a microburst, and then it hits the ground. And yes, the technical meteorological term we tease is called a splat. And if you're in an area where you can actually see any distance and you're able to watch thunderstorms as they splat out, you can often see this across the area. Sometimes the winds are going to be stronger than others, but it's really fascinating to watch as these microbursts form. They can do tornado-like damage. And sometimes you can actually see these. If you're in a thunderstorm, you can actually see the microburst come down. There's like a difference in the density. Even in these pictures here, you can tell the rain-cooled air coming down from these from the thunderstorm here. If you're watching the microburst come down, it can be kind of scary. And a lot of people will insist that it has to be a tornado. It does not have to be a tornado. Wind is scary, and wind is going to sound like a freight train no matter what it is. And even a microburst, like it says here, can do tornado-like damage. So here's an example right here of a storm survey we did back in 2010. And you can see the damage that was done. And this resulted in, here we go, 95-mile-per-hour winds. And this is the same as an EF1 tornado. So very strong winds that microbursts can do. So here's an example in Northeast Tennessee, up near Watauga Lake. You can look at all these snap trees here. And again, people will see this, it had to be a tornado. No, it does not have to be a tornado. Microbursts, straight line winds can do some pretty crazy things, and it does not have to be a tornado. So what we want you guys to tell us, if you see wind damage, if you measure a gust of greater than 50 miles per hour, definitely let us know. Describe the damage. Do you see tree damage? What kind of tree damage? Are they snapped? Are they uprooted? Is it a lot of trees? Is it a concentrated area? Is it a widespread area? Are there structures damaged? What kinds of structures are damaged? Is it siding? Is it windows broken? What is it that you see? The more descriptive you can be, the better. Estimate the size of the downed tree limbs. If it's limbs, are the trees snapped in half? Is it like I said, is it a large area? If you can imagine, say, the size of a football field, okay? What percentage of the trees are down in that football field size area? Is it 10% of the trees down? Is it 25% of the trees down? Anything you can tell us is very, very, very helpful. Are they all falling the same direction? Are they falling over each other? Are they falling away from each other? If you put your fingers out, if you spread your fingers out, do the trees look like that? If your fingers are all spread out, that's what we call a divergent pattern. Or again, are they falling all over each other, on top of each other? That's what we call a convergent pattern. This is all very helpful for us to understand what's going on, because we're going to be looking at the radar ourselves and comparing what you're telling us to what we were seeing on the radar. And again, if you have an anemometer and you can estimate the wind speed, that's very helpful for us. So wall clouds. What is a wall cloud? So a wall cloud is the lowering of the rain-free base. Well, what the heck is a rain-free base? Well, that's the area where a tornado might develop. And the wall cloud is where the tornado would come from in what we call a supercell. We don't get a whole lot of supercells around here. That's more of a plains phenomenon, but we do get a few. So if you're able to watch it, do not ever put yourself in danger. Try to watch for any slow, persistent rotation. Rotation in that wall cloud is the key for any possible tornado development. The wall cloud will typically slope towards the rain. So again, just watch for rotation, and it can be deceptive. Sometimes it looks like it's rotating, but it's really not. It's just moving. So sometimes, again, don't put yourself in danger, but you have to watch it for a little bit. So here's a couple of examples of wall clouds here taken by, these are pictures taken by some of our forecasters on different chases, or maybe when they were back in college and stuff. So here's a couple of examples here. And here's an evolution with a couple of weak tornadoes here. It's just to sort of give you an idea of what it might look like. So once you have a wall cloud form, well, then what is a tornado? Well, the tornado is the column of air that rotates violently, that extends from the cloud base to the ground. Okay, well, that's kind of a crazy definition, right? We could all sort of look at one and tell what one is if you're thinking about the typical definition. But the pictures that are on here aren't going to be what all the tornadoes here in this part of the country look like. So how do the tornadoes form? Well, I talked to you earlier about shear, the change in wind speed or direction with height. So I have here again the definition of wind shear. So if you can put your hands one on top of the other, and if you imagine rolling a pencil between your hands, and then you imagine, okay, because if we have the change that your bottom hand is the wind speeds at one direction, at one height, and your top hand is the wind speed at another height. So that pencil is rolling between your hands. That's going on in the atmosphere all the time. So now we introduce a thunderstorm to the environment. So we have an updraft, and this is this red arrow in the center picture. So now we have an updraft. So now pull your hands so that the updraft is now pulling that horizontal roll vertical. So now your pen or pencil is now vertical. So this is what happens, and it's a very, very, very simplified and idealized view of what happens. Once that horizontal roll is tilted into the vertical by a thunderstorm, in the perfect conditions, that can tighten and be lowered to the ground and form a tornado. Again, that's a very simplified and very idealistic explanation, but that's the basic explanation. However, there are a lot of lookalikes that I want you guys to be aware of. So we've already talked about wall clouds. So a wall cloud isn't a tornado, but it's what a tornado can come from. So here's another example of a wall cloud. And here's another example. But here's another example. So I talked earlier about how when we have that updraft collapsing to the ground and we get those microbursts form, something else that happens when those microbursts form, if you can imagine that cool air hitting the ground and splatting out. As that splats out, that cool air is now rushing away from the thunderstorm. As it rushes away, if you can imagine, it's going to create almost like a teeny tiny little cold front. We call those gust fronts. So on the leading edge of the gust front, because it is a teeny tiny cold front, and if you go back to the very beginning of the presentation where I was talking about the thunderstorm ingredients and I talked about lift, so now you have a teeny tiny cold front rushing away from a thunderstorm. So now we have this gust front or this teeny tiny cold front rushing away from a thunderstorm. That will force air to rise away from a thunderstorm. And what that does is it creates what's called a shelf cloud. away from the thunderstorm, on the leading edge of a thunderstorm. So you guys have probably seen this several times in many thunderstorms across the area. And then behind it, and, you know, it's like this Independence Day look. It's really scary looking behind it. So we've got this greenish, like in this picture, we've got this greenish hue. This shelf cloud looks really scary. This is not a tornado. It's probably very windy because it's got this, because it is on the leading edge of what we call the gust front. It's like I said, it's windy. It's going to be kind of cool behind it because it's kind of, like I said, it is kind of like a teeny tiny little cold front. But like I said, this is not a tornado. This is not, other than being kind of windy there, is not particularly dangerous or anything like that. But because it is kind of scary, we'll lots of times get people sending us pictures of these things. Like, what the heck is this? Like I said, it kind of looks like Independence Day, that alien ship coming in at you sometimes. Another thing that can sort of look like tornadoes, especially at night, would be a rain shaft coming down from a thunderstorm. So imagine lightning illuminating the rain shaft from behind. If you see that at night, this can be kind of scary looking. So this can certainly fool folks. Another one, this is called scud. So we have the updraft underneath the thunderstorm, and so we have all of this rising motion, and with all of this rising motion, you get condensation. So you get all of this with the condensation, you get all these clouds sort of forming underneath the cloud base. So you see all of this funky looking cloud base stuff underneath the main cloud base. So all of this is called scud. So you can imagine if there were something right in front of this scud cloud, this would look like a wall cloud or maybe even a funnel cloud, and this can fool the best of us. We had a report once of a funnel cloud, and we actually had a tornado warning on a storm, and it got us. We got a picture of it, and we just assumed it was a funnel cloud, but it turns out when we got a picture of it from a different angle, it's like, oh well, that's just scud. So again, you got to kind of keep an eye on it, and is it rotating? And that's the big thing. You got to watch it and find out if it's rotating. And sometimes it might look like it's rotating, but it's just got it's going different directions at different levels, and it's kind of undulating and whatever. So scud can really fool you. So the real deal for the tornado, you can see with this box right here, is if you've got debris at the ground. You wouldn't really know that this was a tornado except for the fact that it's actually got debris at the ground. So the circulation in this case does indicate that this one is on the ground. This is a tornado. So tornadoes in the Carolinas and Georgia are not always very photogenic. They don't look very pretty. I mean, it's tornado. We don't really want them, but still, especially this one on the lower left, this sort of looks like scud, but this one actually is a tornado. Sometimes they're obscured by rain, sometimes they're obscured by terrain. They're hard to see. Sometimes even the wall clouds, like the one in the upper right, you know, where's the wall cloud on this? This just looks like it's descended from the base of the thunderstorm. Actually, none of these look like they're really from much of, maybe this one has a bit of a wall cloud. None of these really look like they have much of a wall cloud. This one here in the center here is incredibly rare. This is from the April 2016 outbreak in central North Carolina. So these big ones here are incredibly rare. The very photogenic ones are really, really, really rare. So usually they're small, they're short-lived, and luckily they don't produce a lot of damage. So let's talk about the damage that the tornadoes produce. So the weak tornadoes, EF0, EF1s, these are very, very small, very weak ones. These are about 75% of the tornadoes that we get across the area. And they don't really cause very many deaths. And the ones that do are either because, unfortunately, someone's in the wrong place at the wrong time with a tree falling on them, or they happen to be in a mobile or manufactured home. And frankly, there is no safe place to be in a mobile or manufactured home. They have wind speeds of between 60 and 110 miles per hour. And again, they are very short-lived, 10 minutes or less, have a path 3 miles or less. You know, sometimes they can be on the ground longer than that. But on average, they are on the ground for very, very, very short periods of time, very short periods of time. So here's just some couple of examples of the damage that they produce, very little. But you know, in this case, if this is your house, this is an EF1, if this is your house, it's a very bad day. Very, very, very bad day. So you don't want it to be your house. All right, so let's talk about the strong tornadoes, EF2, EF3 tornadoes. And we do get a few of these. So this is about a quarter of the tornadoes that we see and account for about a quarter of the deaths. And again, for the most part, this would still be trees falling on homes, or this size tornado will pretty much demolish a mobile manufactured home, but will cause substantial damage to a site-built home as well. So we're talking 111 to 165 miles per hour. Those of you who may remember the most recent big one we had, EF3, was in 2020. The one that hit Seneca, South Carolina, that was a strong EF3, and that did quite a bit of damage to some site-built homes and destroyed the Borg-Warner plant and produced our most recent tornado fatality as well. So these are on the ground quite a bit longer and can have quite a long path as well. So some examples here, you can see what this one did to this manufactured home here. Here's a site-built home. A lot of damage there. A lot of damage there. All right, so let's talk about the violent tornadoes. These are the EF4s, EF5s. Only about 2% of the tornadoes across our area, but these cause the most deaths. Wind speeds over 166 miles per hour, and they may last an hour or longer and have a path of 50 plus miles. I would like to point out there has never been a documented EF5 or F5 in North Carolina, South Carolina, or Georgia. Doesn't mean that there hasn't been one. It's just one that we haven't documented. So we started keeping our own documentation since 1950, and there was a project that went back and went through like old newspaper records and stuff like that, and tried to classify old ones, and so hasn't been one documented. And in our forecast area, the last EF4 was in 1989. So, well, it would have been an F4 at the time. We reclassified everything back in, we changed from the F scale to the EF scale in 2007. So it has been quite some time since we've had a 4 in our area. So the last EF4 in South Carolina, I believe it was in 2020, and that was in southern South Carolina. I think North Carolina, the last one was in 2011. And in Georgia, I don't remember if the one, I think they may have had one just a couple of years ago, but it's been, the 4s are very rare. So here's a couple of pictures of what the 4s and 5s can do. We don't want this kind of damage here, of course. But like I said, in our forecast area, the last one was in 1989. So what to look for if you're concerned about a tornado, if you think it might be a tornado? First of all, is it rotating? That's the big one. Is it rotating? Confirm that the funnel is in contact with the ground. Is it small? Is it like a rope, or is it large? Has it caused damage? what direction is the tornado moving and how fast? Now, if you've confirmed that it's in contact with the ground, and of course that it's rotating, if it doesn't look like it's moving, but it's getting bigger, then that means it's moving toward you and you need to take shelter now, okay? So don't worry about contacting us in that point, at that point. Just save yourself and let us know later, okay? So again, if it's rotating and it's in contact with the ground and it doesn't look like it's moving, but it's getting bigger, then it's moving towards you. So take shelter. Do not ever put yourself in danger to get a report for us, please. Your life is much more important than the report. All right, so let's talk about a few tornado myths. One myth is that tornadoes never impact big or major cities. A tornado doesn't care. It does not care. So here's just an example of 1999 in Salt Lake City. Their tornado hit Little Rock, Arkansas. Tornado hit Fort Worth, Texas. Tornado doesn't care. It does not care. Okay. Tornadoes never develop in high elevations. There's something to be said for the friction of the mountains, and it's slightly less likely. But the bottom line, the tornado doesn't care. If the tornado is, especially once it's on the ground, we can go back to the 2011 outbreak, and one went across, it went into the North Georgia mountains, went into the Smokies. The tornado doesn't care. Myth: if I live on a hill or at the bottom of a valley, I am safe from a tornado. Well, I hope you heard what I said with the last couple of slides. The tornado doesn't care. It's an inanimate, well, it's moving, but it's an inanimate object. It does not care, especially once it's on the ground. Nothing is going to stop it. It will travel up the hill. It will travel down the hill. Nothing is going to stop it. It does not care. A tornado never crosses a river or lake. Well, hopefully you heard what I said the last 4 slides. A tornado doesn't care. I just surveyed earlier this year where a tornado crossed Lake Norman, because we had damage on one side, on the which side of it was it? The Catawba side, and it crossed over to the Iredell side. The tornado does not care. If you are on the road, get off the road. Find shelter somewhere else. Do not ever take shelter under an overpass, because that just causes all sorts of problems for everybody else. But it actually acts sort of as a wind tunnel, and the wind speeds will pick up under the overpass. Don't seek shelter under a tree. Get off the road and find shelter someplace else, okay? So if you happen to be on the road and you're spotting for us, like I said, we don't endorse chasing, but if you are spotting, please seek shelter. So again, just going through some of what we've been talking about, tornadoes, large hail, severe winds. Please make sure you are safe no matter what you are doing. Okay. All right, let's talk about flooding, because while I understand that the severe weather is for the weather weenies among us all, the severe weather is the cool stuff. It's the flooding that's killing people around here, okay? So let's talk about that for a little bit. So we get flooding happening from high precipitation thunderstorms, from slow moving storms, from lines of storms. If you can imagine a train going across a train track, and if you imagine the trains going across one location on the train track. So think of storms going across one location repeatedly, just like trains. So we call this training storms. So this is what happens lots of times, how we get flooding as well. Large storm systems, tropical systems. We're actually in a bit of a drought right now, so because we didn't get the tropical systems that we usually get this year. But flooding is a real problem across our area. And you can see with all of the things, all of the types of storm systems that we get across the area, we can have flooding any time of year, really. So we really want people to take things seriously, the flooding seriously. Most flash flood deaths occur in vehicles, and usually it's because of poor choices that folks make driving into the floodwaters. But sometimes, like if they're driving at night, sometimes they can't see it, and that happens all too often. But there are plenty of times that there's nothing they can do about it. We have mountains, we have terrain. Sometimes it's the water just comes down off the mountains and there's not a darn thing they can do about it. Most flash flood deaths occur at night. And of course, the flash flooding can occur from distant storms. The flash flooding can be from the storm on top of the mountain, and then that water can come down the mountain or it can come down the river, and it can sweep people away, and they didn't even really realize how far away it was. Flooding can completely wash away the road. And the real problem is that, like, if you go back to that first picture I showed, okay, this car driving across this road, that muddy water, can you imagine? Okay, you can't see that yellow line anymore. What if underneath that muddy water was this situation? And if you can't see that yellow line, you don't even know if the road is there. So just don't do it. If you can't see the yellow line, don't drive across it. Don't let anybody else drive across it. Do not ever drive around barricades. Don't do it. Please don't ever, ever, ever do it. 12 inches of water can carry away a car. 18 to 24 inches can carry away SUVs, vans, and trucks. And all it takes is 6 inches of water to knock over a person, and much less for a child. So don't ever let kids play in floodwaters. And there's all sorts of crud and crap in the water too. So another hazard that we deal with here in the Western Carolinas and Northeast Georgia is the landslides. And, you know, we dealt with this with the remnants of Tropical Storm Fred a couple of years ago. Back in 2004, we dealt with this with the remnants of Ivan. So this happens over and over and over again. So when we get too much rain in a short period of time, we can get these slope failures in the mountains. So this is known as a landslide or a debris flow. So this one here, the picture here is from the Peaks Creek debris flow. This is from 2004. And it's deceptive. So the picture here, the blue arrow is the origination of the debris flow. And the yellow arrow is about where the picture was taken, it's here at the bottom. And you don't realize how big this is, the picture at the bottom, when you're looking here at the picture of the upper left. I mean, that's huge. And we had, I believe, 5 fatalities with that one. It just swept whole homes away. It was just awful. And when that water starts picking up the land and the trees and the rocks and the debris, there is nothing stopping it. It's just terrifying. So here's a picture of what happened with Fred in 2021. Here was the before picture on the left, and here is the after picture on the right. And we had 1 fatality with this particular landslide. We had additional fatalities with the flash flooding. It's all very devastating. So what we have found that when we get 5 inches of rainfall in 24 hours, we get isolated landslide activity, and up to 10 inches, we get widespread landslide activity. And of course, that depends on the amount of rainfall prior to the heavy rainfall event. So with Fred, we had rainfall prior to it. There are some clues for landslides. So if you're out in the mountains and you see trees that look like this is a slope that is slowly giving way. The slope is moving underneath the tree. If you see roads that look like this slope is moving underneath the road. If there are cracks in pavement or masonry, cracks in the chimney, then it's moving. But the big clues are, of course, the road and the trees. So if you're out there camping, or if you're out there, looking for property or whatever, don't buy property with a bunch of curved trees that look like this. But especially if you're out camping, please pay attention. If there's a flood watch, and if you're camping by a river, or if you're at a cabin by a river and there's a flood watch, be prepared to get out, and please, please, please help those around to understand what all this means as well. So just like the severe thunderstorm and tornado watch and the severe thunderstorm and tornado warning, the flood watch means that flooding is possible, and the flood warning means that it's happening or imminent. We have one other level of flood products that we issue as well, and we call this a flood advisory. And this is sort of like kind of nuisance flooding. And it just means use caution when driving. We might, areas that are might have low water issues, or low water crossings, stuff like that. So parking lots that might typically have water in them, we might issue a flood advisory for that. And then we've got two different types of what we call the flood warnings. There's the flood warning and then the flash flood warning. So, and the difference in that isn't necessarily severity, but time. And you can see here, this is gradual for a flood warning, and a flash flood warning is rapid, okay? So they can both be severe. They can both be very high water. But with a flood warning, there might be time to move property to higher ground. With a flash flood warning, there is no time to move property. You need to seek higher ground now. Okay, it's the time. Again, this is rapid flooding with a flash flood warning. And then our last level is what we call a flash flood emergency. And this is rapid, major, or record flooding, something that is seldom seen. This is a very, very, very big deal. So if you think back, for those of you who were familiar with what happened with Tropical Storm Fred up in Haywood County, think to that. That is a flash flood emergency. Do not get on the roads unless you are fleeing. Your life is in imminent danger in this situation, okay? So this is a very, very, very big deal. So why am I going over the warnings, what the different warnings mean for you guys for these flooding? Well, because you guys as spotters also don't need to be out on the roads during the flooding, but we want you guys to tell us what you're seeing, right? So what is it that we want you guys to report for us for flooding? How deep is the water? Tell us in relation to other common things, like, is it impacting property? Are there roads closed? Is the water flowing or standing? Is there a creek nearby that the water is coming out of? Like I said, is it impacting property? Are yards or homes or businesses flooding? Is it in basements or is it in first floors? Is the flooding in this area unusual? Like I talked about that flood advisory thing. If it's a nuisance flooding and it happens all the time, that tells us more, okay, maybe we should issue a flood advisory because because folks around here are more used to it. But if this isn't happening before, this is when we need to upgrade and issue a different type of product. And like I said, are there any nearby creeks or streams? How far out of its bank is the creek or the stream? Okay, So you guys are probably all aware of the warnings that come across on your phones. So this is called the wireless emergency alerts. And these are messages sent by authorized government alerting authorities through your mobile carrier. So you've probably all had the really annoying buzzing sounds on your phones when we've issued tornado warnings. So this is for tornado warnings and some flash flood warnings. You don't have to sign up for them. It's automatic for when you get your device. Again, it's sent automatically to these, what we call WEA, wireless emergency alert, WEA capable phones during an emergency. That's just one way to get a warning. There are other ways to get a warning, like NOAA Weather Radio, Twitter, your favorite app, whatever. We don't have an app for the Weather Service, but this is just one way to get a warning. Like I said, they are issued for tornado warnings, all tornado warnings, some severe thunderstorm warnings when the damage threat is destructive, and that's when we're expecting 80-mile-per-hour winds or more. Flash flooding, not all flash floodings, only when we're damage threat is considerable or catastrophic, and that is basically when we're expecting what we call moderate or major flooding or higher. Hurricane warning, tsunami warning, storm surge warning, extreme wind warning, dust storm, or snow squall. Now, what are all these and why are they important? Well, we don't issue tsunami warnings for here, for example, but if you're along the coast, you might get one. Extreme wind warning, that is in the eye wall of a hurricane. So if you're ever along the coast, I hope not. I hope you would be evacuated in that case, but those would be issued. Dust storm warnings, we would probably never issue one around here, but if you're ever out west, you might get one. Snow squall warnings, those would be more of a product for up north. But if you're ever up north in the wintertime, you might get a snow squall warning. So here's just an example. We picked out Mecklenburg County, so people within this box would get the wireless emergency alert on their phone for a tornado warning. So when to call in a report, basically we need to know who you are, that you are a spotter, what you have seen, the type of weather, where the event is occurring, when the event happened. So what do you report? Hail, please estimate the size for us. And again, don't use a marble, use it in relation to a coin or a ball. Tornado or funnel cloud, and try to estimate the location as best you can. Any significant flooding. Wind damage, please describe it to the best of your ability. Of course, if you see lightning damage, please let us know that as well. We do have an additional resource for you. There is online national spotter training. It's not going to be geared toward the Southeast, but if you're a real weather weenie and would like to take additional training, you are welcome to at this website, or you can use the QR code on this page here. So you could take that, and we will be sent your information once you've completed the course. It is not required. Once you finish this course here, you would be considered a trained spotter for our office. But before you do that, we would like for you to register with our office so that we have your information. So a couple things we want you to do, first of all, is to fill out this spotter registration form here. So weather.gov/GSP/GSP spotter form. If you would please go on there and fill out that form, and you can choose on the drop-down menu that you have completed the basic spotter training. And then to report severe weather, go to this website here, weather.gov/GSP/reporting, and there will be an online form for you to fill out. And it also has the phone number there, but the phone number is here on this slide as well. This is a monitored voicemail. So when you start calling in, you would start to leave a message, and you would say that, hey, I'm a spotter, this is where I'm located, this is what I'm seeing. And because usually when you're calling in to let us know about a severe weather event, we're in the middle of a severe weather episode, so sometimes our forecasters can't get to the phone. But if there is somebody free, they will jump over there and pick up the phone and start talking to you as you're leaving your message. And we do have an email address that you are welcome to send pictures and stuff to, gsp.spotter@noaa.gov. And you are welcome to follow us on Facebook and I guess no longer Twitter, I guess it's X now, but at NWSGSP and U.S. National Weather Service, Greenville, Spartanburg, South Carolina. If you are on those social media platforms, we would be happy to have you follow us and send us your pictures of your severe weather phenomena that you see there as well. And with that, let me see. I will check to see if there are any questions here. I do see one, I see a couple of questions. Let me pull out these questions. All right. What is the difference between a microburst and a downburst, or are they the same? They are the same. Every microburst is a downburst. There are two different types of downburst. There's a microburst and a macroburst. So a microburst is smaller, a macroburst is larger, and I'm probably going to get this wrong. I think a macroburst is 5 miles, and a microburst is smaller than that. It's a size thing, but they're both downbursts. I'd have to look it up. We typically just call them all microbursts, but if it's larger, it's called a macroburst. Okay, another question here. What is an aerial flood warning in comparison? Okay, aerial flood warning, we just call them all flood warnings now. So a flood warning and an aerial flood warning, we really sort of just drop the name aerial. So there's a flood warning and then there's a flash flood warning. So an aerial used to mean it was spread out over an area, a larger area. And then there was the flash flood warning, it meant flashy and like a smaller flashy area. But people were getting confused at the term aerial. And so we dropped the term aerial. So it's a flood warning, meaning that it's a longer duration, greater than 6 hours since the causative rain. And then there's the flash flood warning and less than 6 hours from the causative rain. So that's the two differences there. And then the last question is, MPing still a helpful way to report severe weather? Is this being monitored by NWS-GSP? Absolutely. We have MPing open all the time, especially during winter weather. We love MPing during winter weather because we'll have that open and we'll see all the little snowflakes and then raindrops turning to snowflakes and stuff like that. So yes, we use MPing all the time at our office. Absolutely. So use that as much as you would like. And let's see, are there any other questions? I don't see any others coming in. Well, with that, I really appreciate everybody's time. Thank you all for joining us this evening, and congratulations on sitting through the spotter course and becoming a trained spotter. Again, I will come back to this page. Please remember to fill out the GSP spotter form for your spotter registration. You will receive a certificate in the mail. If you don't get it immediately, check your spam. We've never not had it work, but if it doesn't work, feel free to email the gsp.spotter@noaa.gov email and we will troubleshoot it. So otherwise, you guys have a good rest of your evening. Thank you for joining us, and thank you so much for your dedication to helping us with and becoming a spotter. So thank you so much. Have a great night.